So in this video, we are going to look at bond energies and how does the bond energy relate to the delta H of the reaction, or the change in enthalpy for the chemical reaction. So if you remember, in the direct method, they give you standard enthalpies of formation. So direct method is delta H of formation for each substance. And that was using products minus reactants. So if I have delta H formation, use products, the sum of the products minus the sum of the reactants. For this method, this is the bond energy. That's not the enthalpy of formation. So this is actually the energy it takes that each bond has, or the energy it takes to break the bonds. Okay, and so if you remember from last year, bond breaking, remember bond breaking is energy in. Okay, I gotta put energy in to break the bonds. That means all this stuff here, I gotta break first. So that is the upswing of the energy diagram. And then bond forming is energy out. So that's the downswing of the energy diagram. And it's either gonna end up higher or end up lower, depending on what kind of reaction it is. If it releases energy, if it's exothermic, then you're gonna have more energy going down. If it's endothermic, it's not gonna be as much energy going down. So I'm gonna show you how to do this question here. This is 914. And for this question, we need another piece of information from the information above here. So I'm gonna grab the bond energy for the HH bond, and that is 436.4 kilojoules per mole of bonds. So I'm going to take all the bonds here in the beginning. I'm going to add them up first, and that's my energy in. So I have two H2 bonds, so 2 times 436.4. And I'm going to add it to my O2 bond. Now remember, O2 is a double bond, so it's not this one, so we're not going to use this one at all. So 498.7. Okay, so if I do that math, 2 times 4 plus 498.7, that is 1371.5 kilojoules per mole. And this is energy in. Okay, now I have water here. Water is H2O, like this, but it's 2 of them. And each of them has an OH bond. So I'm gonna go ahead and take 460 times 2 of these, but there's 2 waters. So there's 4 total. So 460 times 4, that is 1840 kilojoules per mole energy out. And then what I do is I just take my energy in and subtract energy out, because energy in is up, energy out is down. This energy out is bigger, so that's going to be 1371.5 minus 1840. So 1371. So that's going to be negative 468.5 kilojoules per mole. So that is my delta H of reaction up here. Negative 468.5 kilojoules per mole. So that's how you use bond energies to figure out the delta H. So do this problem here as a class. If you flip the page, I'm going to do this problem down here. So now it's the reverse. They give you the enthalpy of reaction. This is delta H of the reaction. That's negative 119 kilojoules per mole. And this is my reaction here. So assuming CH bond enthalpies of these things is all pretty much the same, of C2H4 and C2H6. Figured out the CH bond enthalpy for this reaction here. So same way, I'm just gonna set it up for you, you can solve this. All the bonds in, to break those, that's my H2 bond, so 436.4 kilojoules per mole, plus C2H4 looks like this. So C2H4 is C2H4. So because there's only 4 H's, I need to make a double bond here, because every carbon has to have 4 bonds. So I was going to have this bond here, 620, plus 1, 2, 3, 4 of these CH bonds. I'm going to call that X, okay? So CH bond is X, X is CH bond. So that's going to equal, sorry, not going to equal anything. All this stuff here is my bond energy in, minus my energy of forming bonds. So C2H6 looks like this, C2H6. Okay, so there's a C bond here, single, 347, plus 1, 2, 3, 4, 5, 6 X, because X is my CH bond. So energy in minus energy out equals negative 119 kilojoules. And then if I do some algebra, make sure that I have, combine my terms and all that stuff. I'm basically solving for X, okay? So that's how you start that problem. I think problem 32 is a little easier, so you can probably try that one yourself. Remember the same thing, energy in minus energy out for bond forming. That equals my delta H. Okay, good luck.